Hi, my name is Paco Nathan, and I'm managing partner at Darwin.ai. And I love espresso. I prefer drinking Southern Italian, Sicilian kind of dark roast espresso. And also, I'm really particular. I really love making it in a mocha pot. So I have a few cups of those every day.
Hello and welcome back to another MLOps community podcast. I am your host, Dimitri Os, and today I've been doing something that I have not done in a while, which is putting lime on my chips and then adding a little bit of Valentina sauce. Shout out, because if you know, you know. I gave a little bit to my daughter and I thought it was hilarious since the chips themselves were organic, and the Valentina sauce, if you ever look at the ingredients on that hot sauce, it is just letters and numbers. There are no legible words on there unless you are a chemist. You can understand what it is comprised of. So why even have the organic chips if you're going to put some Valentina sauce on it? I don't know. These are my personal musings, and that is not all that I was musing about today. Our guest was incredible. Paco blew my mind with so many places that he stopped, he explained things, and wow, this man has been in the game, in the NLP game for years, decades even. And he's still doing it. He's still firing on all cylinders. Today we talked about some of the trends he's been seeing in his job, whether it is small ensemble models versus large language models, or different boring use cases, because he deals a lot with manufacturing and companies in the EU that have GDPR compliances that they need to deal with. And I was expecting him to say, yeah, when I'm working with factories or these other manufacturing companies, I'm getting all kinds of sensor data and I'm having to do AI at the edge and all that fun stuff. No, I don't want to spoil it for you, but it was not that. That was not the lowest hanging fruit and the highest leveraged, highest money-making use cases for AI in these types of boring companies. And last but not least, this man was on a conference rampage over the last quarter, and he gives us a breakdown of all of the talks that really made a dent on him. And he would know because he helps organize and find speakers for some of the most prestigious in-person conferences, one of them being the AI conference. I mean, the more I talked to Paco, the more he blew me away. He told me all about his story, and he also told me some little tidbits, like breadcrumbs along the way, how he used to work for O'Reilly, or he worked with Ben Yorka for a little while, Ben Yorka being one of the famous members in the ML community. He also talked about how he was one of the first people and the heaviest users on AWS when he was using Hadoop clusters. That was something we got right into at the start, so I'll let you go and enjoy that. And if you want to give your taste buds a little bit of a party, go ahead and throw some lime on your tortilla chips and top it off with some Valentina hot sauce. Let's have a good session. See you all in a minute. Paco, it's great to have you here.
How do you choose?
I want you to know that you're slowly becoming my favorite Paco that I know about. And right now, there is one other Paco in my life. And I think you probably have a hunch which Paco I'm thinking about, because you spent some time in España.
That's fine.
And for those who have or that know about España and the history there, you can't go anywhere without paying homage to Paco de Lucia.
Oh, certainly. Me encanta España. Me encanta mucho los españoles. Y Paco Lucia.
Paco de Lucia, claro. So yeah, I lived in the northern part of Spain, which doesn't like to call itself Spain,
Wait,
in the Basque
where?
Country for a while.
Oh, really? Well, around what city?
Bilbao.
Oh, beautiful. Oh,
Bilbao.
that's incredible. Yeah.
Yeah, so I know you're now up in the redwoods in California, and you're doing all kinds of stuff. It seems like we've taken similar life paths. I'm in the middle of nowhere also, and trying to work on AI stuff. You are similarly doing that and helping all kinds of companies, working on all kinds of open source projects. I think it's probably worth giving people a bit of an idea of what you're working on right now when it comes to the different open source projects. I know you're a super connector, as I like to say, and I try to be one of those too. And so you've got your fingers in a lot of different things. Can you break it down for us real fast?
Thank you. Well, as far as I'm at Derwent, and as far as what we do is working mostly in enterprise for machine learning applications, natural language and graph technologies a lot. But the idea is that, enterprise teams probably are checking out papers as they're coming out and seeing, hey, look, there's some really good stuff going on here. Maybe we could apply this. It's really hard for enterprise teams to have all the resources to take, like, here's the latest and greatest research, but let's vet it. Let's, go ahead and check this out. Check out the open source that's associated. Does it run? Does it actually install properly? Does it actually reproduce the results? Does it fit the use cases that you have? So that process, like bridging that gulf between here's the latest stuff that's being published and can somebody else actually use this code in production? That's a pretty big gulf. And so that's a lot of what we do. But it generally has to do with like integration paths for graph technologies and natural language and, various areas of machine learning. I really came from more of a natural language background. I did machine learning back in the, early to mid 80s, when I was at Stanford in grad school, and nobody cared for a long time. I started doing neural network in like 1984 and had some really interesting projects, but for a long time, nobody really cared. But then I led data teams for about 10 years in the industry, kind of when like data science was becoming a thing. Our teams were guinea pigs for a new service called AWS. So I got to kind of be on the ground floor trying out and giving a lot of feedback there. And eventually I was the community like evangelist, if you will, for Apache Spark when we started going through hypergrowth period. And that was really fun as far as seeing open source and just the impact on the industry. But these days, a lot of what led me into graphs were interesting graph algorithm applications in natural language understanding. And I've been doing some work in open source for about 15 years in that area. I'm implementing algorithms that were coming out of a particular lab. And they get, one of our projects I think has like 2,000 stars. It's called PyTextRank. But that got me into graph technologies, graph algorithms, graph machine learning. And that's a lot of where I've spent the past few years, because I think there's been a lot of interest on the research side. Certainly, there was a period where if you wanted to get your paper published, you had to mention GNN. But there's not a lot of industry adoption. So I'm really interested in areas, most of our work is in Europe, mostly European manufacturing. And I do spend time in Spain and Germany. And, I'm really interested in where can we apply natural language and graph technologies in manufacturing. And then on top of that, I'm also helping out advise different startups. There's one called Arguila that's based in Madrid and Valencia, and there's also some other startups and concerns over in Galicia that I really like, and a few on the US side too.
Okay, so all kinds of graph stuff happening and all kinds of fun stuff in the open source world. I think you glossed over something that I want to backtrack and just make sure that we touch on. That is your basically front seat in that rocket ship, which was the AWS and the Hadoop days and what that all looked like. And can you break that down for us? Like paint the scene, paint the picture.
Yeah, Hadoop days, that was pretty interesting. I got pulled in to be a technical co-founder for a startup in 2006. And prior to that, a friend of mine, Jason Levitt, had gone up to Seattle and was calling me up and giving me these bizarre questions of like, if you had the following, what would you do with it? And I'd be like, Jason, that doesn't exist. But anyway, it turned out to be AWS. So in the middle of 2006, I got pulled in as a technical co-founder, and it was called Head Case Human Manufacturing. We had this wacky idea of using NLP in social media and basically data mining a lot of stuff. And we were doing things like in Second Life, and it was pretty wacky, but it was a little too early, but it's still pretty fun. I went to the VCs and I said, hey, there's this thing called AWS. I think that rather than like signing a lot of contracts with, some hosting service, we should go into this thing called the cloud. And John Callahan at True Ventures, he backed me up on that. And so we became, I think, the third company outside of Amazon to go 100% cloud. And I got really involved in the user community, but also with the different services, and was kind of a guinea pig there. We were doing NLP on EC2 really early. This is like 2006. And we
Can't imagine what the developer experience of EC2 in 2006 was, because I know it's still painful. So
it was
in 2006, I really wonder.
Well, in some ways there were less choices, so it was a little bit more explicit about what you had to do. But yeah, it started out with S3 and then EC2 and then other services. But we ran into some bottlenecks, so we started using this there was this open source project that had just been released in like December 2006 called Hadoop. So we started using that and got in on the ground floor there. And long story short, a couple of years later, our startup got rolled up, put into a large ad network, and they were getting rid of a large IBM project called Netezza. They'd spent a lot of money on it and it was failing, and they wanted to replace it with Hadoop. So our team came in and reverse engineered and like started working on this. And there was this bottleneck at the time on EC2 where like the IO, it just really wasn't going to work out a large Hadoop cluster on EC2. But there was this one guy named Tom White, consultant, and his name was on the Jira ticket. So we hired him, as a consultant, and I, wrote the check out for like $3,000, and he put in a PR to Hadoop to make it run on EC2. And we started firing it up. And then my friends from Amazon called up and said, hey, look, you're one of the largest Hadoop clusters in the cloud. We need to talk.
Oh, wow.
And so we became a case study for, at the time, it was called Project 157. It was later Elastic MapReduce. And so,
Wow.
It was really fun to see how can we for instance, there we had $3 million worth of Netezza with $1 million a year maintenance, basically. And, we wiped that off the table. It had like an 11-hour batch job that was responsible for most of the revenue in the company for the recommender system being refreshed. And this machine learning workload was just like failing at like hour 9 or hour 10, and you didn't have time to restart it. So we wiped out $3 million of CapEx with like $400 a day of OpEx. And we allowed the business to be able to scale that depending on, what do they have incoming. And the economics of it were just fantastic. But also it just really led me down the path of like, here's some real practical experience of, how to do big data in the cloud. That was pretty early on. And next thing I knew, I was doing a guest lecture at Berkeley about it. And I met a bunch of people who would go on to found a company called Databricks.
So you were the predecessor. Yeah, you planted the seed to Mate and Spark and all that fun stuff then, I guess.
Well, they were on their way. I think the person who really planted the seed was probably David Patterson. There was a video online of like David Patterson grilling me about this. If you ever want to see me really, making a fool of myself in front of a bunch of people. But Patterson was really trying to understand, and he was collecting experience from people who'd really worked at scale to see what the cloud could or couldn't do. I think this was 2009. So it's pretty fun. The thing that we were dealing with back then is like the hedge funds. They would just grab lots and lots of instances and figure out which ones had good performance, which ones were kind of failing. And then they would throw away the ones that were failing. So if you came in at the wrong time of day, you would grab all of the really bad instances, basically. So anyway, there were little nuances back then. Amazon, of course, has done so much work over the years. Yeah, it was pretty interesting. And then from there, going into Spark and just seeing all of that take off. I was also very much involved in Project Jupyter, Jupyter Notebooks and that community. I was for I think the first conference I was co-chair. So yeah, very interesting to see what's happened in data engineering, data science, machine learning, and the open source behind it.
How do you feel about the way that things have evolved? And if you, I guess that's a little bit too broad of a question. Maybe we can narrow it down some more. As you look at the evolution, and it feels like there are ways that things have specialized so much more.
Yeah.
And now it's not just, hey, there's this cool thing called Jupyter Notebooks. There's a plethora of options of notebooks that you can use that have their strengths. And then it's not this thing called Spark, but you have many different ways that you can be using a type of Spark-like thing. When you look at this evolution, do you feel any certain nostalgia for the days of, when back in my day it was easier because you had less options? Or is there ways that you are anticipating it is going to continue growing and continue like pushing the envelope and where you want to see it go, I guess?
Yeah, no, that's a great question. I mean, I think one of the issues is that VC funded startups really want to go after having a platform and selling an enterprise license for some platform. So the idea of like taking different areas of open source that are successful and then commercializing them by having a very opinionated platform, that's something that's just like never ending because the money keeps wanting it. On the other hand, what I really see is there's this long-term arc where people are less and less interested in platforms for day-to-day, or rather I should say that as a practice becomes more normalized and more generalized, then people don't want a big heavyweight platform. They want a library and they want to run at the app layer. They don't want to have like an army of ops people maintaining their Hadoop cluster, right? And you see this because like the applications that we were running in 2008, that required extra large instances on EC2 and this whole Hadoop cluster and like, a team managing it. A couple years later, 2009, I went and rewrote that in Python and ran it on my laptop and it ran faster. And so because of how much hardware is driving all of the evolution of this, I mean, my take is like hardware changes and that drives software changes and that drives process changes. I think a lot of people look at it the other way, thinking that hardware is like way far away from you and you must deal in an agile process. But it's the hardware and the economics of hardware that are changing things. And I think that the hardware side is evolving faster than the software side, is my take. So that's where you see, this kind of upside down equation of like, here's a ginormous platform that everybody's using. And 2 years later, it's like nobody even knows about it anymore.
Holy shit. So many things just made so much sense in my mind on the platforms, the way that I like that a lot, how you talk about not only is it on the technical side of things, but the organizational side of things.
Yeah.
Because now if it is easier, if the hardware has enabled the software, it's going to enable the developer. And on a microcosm, we see that with what's happening with LLMs, enabling the software developers to now leverage AI. But you also have that where the first generation, if we can call it that, of like MLOps platforms, like your Domino Data Labs and such, and even Data Robots, those were those heavy platforms also. And now, because of the advancements, you have the ability to just say, hey, I'm going to install a library, or it's, pip install MLflow.
Right.
And that gets me pretty far.
Yeah. And maybe, I mean, I'm sure there's going to be use cases that really need a lot of extra attention and a lot of specialized tooling. And when you look at companies like NVIDIA, really they go after those big, huge, ginormous use cases like Walmart recommenders, and they build hardware for that. And everybody else sort of, uses whatever the big cases have impelled, right? And so I think that, yeah, on the software side and the platform side, there will still continue to be really big cases, but they'll probably be more purpose-built. But at the end of the day, if you can get, 80 or 90% of what you need by installing some open source library, the economics of it work out so much better. There's a little mini book that Dean Wampler and I did for NVIDIA. It's called Hardware is Greater Than Software is Greater Than Process. And I can give you links to it, but it kind of goes through some of this and tries to give a little bit more of an empirical background for it.
Well, I like how you said that most people have it backwards, that we think, oh, if we do the agile and we set up our processes, then everything else will fall into line. But it's not possible without that hardware innovation. And I'm going to subscribe to that. I could see that. It makes total sense. I haven't totally dug in and researched it or anything, but it makes complete sense to me, because you're not going to have the data scientist who can leverage so much more at their fingertips if you don't have that hardware that is the underlying support.
And I think, taking this out a few years ahead, looking ahead at the horizon right now, in the LLM space, what we're seeing is, yes, people use clusters of GPUs to train really large models. That's true. But most of the use cases probably are going more toward like smaller or specialized models, or using mixture of experts, kind of a lot of models. And at runtime, they're not going to be running a GPU cluster. They're probably running much cheaper hardware for inference. And at Race Summit, it seemed like every keynote was a different vendor coming out and saying, our specialized inference hardware runs 2x, the ROI of NVIDIA. So I think that this is what we're seeing is, on the inference side, it's not a CPU-bound game. It's more of an I/O-bound game, because you don't want starvation in the models, and you're worried much more about things like concurrency, and a lot more software engineering goes into the inference side, the use case side, and a lot less people are training models from scratch. So, I think the hardware is becoming differentiated more, and oddly enough, at a very rapid pace, and that's going to be a lot of the game for AI in like the next 2 to 3 year timeframe.
Wow. So there's so many ways that I want to go. I think you mentioned we should probably pull on the thread of this ensemble models and the specialized models. And when do we get small models, small language models? What are we going to start calling these? We need a different name. And then the other piece that I want to just put a fork in too, and say that I would love to come back to, is some of your learnings from all of these conferences that you've been at, because I know you did the whole roadshow recently. And so you probably have a lot of incredible stuff that you learned about in all these different keynotes and presentations that were at the different conferences. But let's harp on the idea of these ensemble models and smaller models, and what your feeling is like. Just again, paint us the picture of, we know the problems with large language models. We do understand that 90% of what you need that a large language model can do, it can do with much smaller models, right? You do not need a model that can write you prose about the meaning in life in the style of Bob Dylan if you're adding an AI feature that will turn your text to SQL. That is, the SQL might be quite rememberable, but it is not necessary to have that ability for these smaller use cases. And so when it comes to smaller ensemble models and then running them, you work a lot with different companies that have really strong hardware constraints. I get the feeling whether it's manufacturing. I know you're not using a language model at the edge on a manufacturing use case, but I do feel like there are probably things that you've seen when it comes to how these are being set up to win. And right now, like, what is beyond just hitting OpenAI's API?
Yeah, exactly. Great question. Well, I'll reference a few people. So I think one of the best talks, the AI conference in San Francisco, Ben Lorica was chair. Really great conference, sold out hard. A lot of great learnings there. One of the most popular talks was Waleed Kadus, who's chief scientist at Anyscale. And I tell you, I mean, I was
friend of the
MC,
pod.
and
Love that guy.
I recommend go check out that video because I was MC. I had to ask, like, Waleed was trying to come off stage and he got swamped by people, and I had to be polite because we had other speakers coming, and Ben and I went and checked, and Waleed was still being swarmed by people with questions an hour later out in the hallway. And he was showing it's like, hey, yeah, you could use a really ginormous God model and pay a lot of money and send your data out there. Or you could use an ensemble of other smaller specialized models. And okay, maybe you do something really expensive as like a jurist or whatever you want to call it, but at the end for some QA. But what Waleed was showing is go with the smaller models in an ensemble. And by the way, we've run this at scale, and we've run the numbers, and we can reduce your cost basis by about an order of magnitude, while preserving a lot more data privacy and, a lot more security and things like that. So this is what people care about in enterprise. So I definitely recommend his video. Also, Christopher Wynn used to be engineering director for Gmail at Google. He was the person at Google who said, hey, this neural network stuff, we should check it out. So Christopher Wynn at K-First World this year, he did a opening keynote about small specialized models. And the idea is that in industry, this is more of what people care about, is find the tasks that you need, do a lot of task analysis up front, select really narrow focused tasks where you have good evals for them, and then use models there, probably use an ensemble of models there, as opposed to having some enormous God model. I think like you were saying, your enormous God model might, render a lot of interesting poetry for you, but that's not what you need if you're trying to translate into SQL schema. That's just kind of the definition of feature creep right there. So anyway, Christopher Wynn's talk, I think, is really good about setting a stake in the ground for small specialized models. And the other person I'd really reference also at the AI conference was Mark Huang from Gradient. He did a thing called A Million Models. He did a talk. It was one of the keynotes, one of my favorites. And the point that he was making is that, okay, when you go out to synthesize an answer in generative AI, if you just train one model, you're going to get some hallucinations, etc. What if instead, let's go ahead and here's the embeddings for, let's say, what procurement would say, and here's the embeddings for what security would say, and here's the embeddings for what legal would say, and now let's re-rank those so that we can actually get a mixture of experts before we go out and synthesize the answer. So I think that the Million Models talk is really, really good there. He shows, it's great slides too, by the way. So we can link those. But I think that that's kind of the perspective that we're hearing from a lot of enterprise, and for me, it's mostly enterprise out of either Europe or Asia, but a lot of those enterprise AI teams that have very significant apps, this is certainly where they're going. They most certainly are not going to send their most confidential data out to a third party. That's just not going to happen. They don't want to have any kind of managed hosting. They want to run things internally, whether it's in their cloud perimeter or on-prem, but they want to run it. And so they also want open source because they want to have their security people vet what's going on. And, they want to have risk analysis by looking at the models and looking at the evals. And so I think that what Christopher Wynn and others are seeing about small specialized models, it's certainly resonating in industry right now. Oh, and one other thing. Okay, the other proof point. I think the proof point that really ties it down is I will recommend Useful Sensors if you haven't seen it already. But a group of people from DeepMind split off. It's led by Pete Warden and Mendrath Kudlur. And anyway, Pete was the technical team lead for TensorFlow Mobile for 8 years. And Pete's firm Jetpack had been acquired when Google bought DeepMind to coalesce and bring together DeepMind. And then Mendrath he was one of the people who, if I got the story straight, one of the people who wrote the CUDA compiler at NVIDIA, and Google brought him in to help build TensorFlow. And those guys are out doing a startup now. And if you look at it, they've got a thing called AI in a box, but basically there's $50 worth of hardware. It's running 3 LLMs. And, they can do, well, they're doing like Whisper and Llama 2 and also the Meta No Language Left Behind model. But, like here's a little chatbot that's actually really good that can translate languages and do amazing, voice to text even in a noisy environment. And it's running on low power on a really low cost hardware. It's running on a ROC chip, which is like an ARM with a neural processing accelerator. It's like an 8-core chip. And the thing is running 4-bit models, and it's mostly IO bound. It's a lot of, like I say, a lot of concurrency game. But those folks at Useful Sensors, they were inside DeepMind. They were the people like building the tools to build the AI models for Google for years. And I think that their narrative and what they're showing is such an incredible counterfactual to what's going on in the news cycle, because the news cycle is all about there's one company that's dominant and you have to have an enormous cluster. And it's like, no, actually, you could run this on like, really low power, low cost hardware.
Then it comes down to what are those specific use cases that you're trying to solve for? What are you actually doing? It's not necessarily letting your creativity run wild, and how can you leverage what's out there, because you don't have to be bound by an OpenAI API call. And so I think for the question that I had, like what's beyond the OpenAI API calls, that was one hell of an answer. I'm going to try and figure out, like, the one thing that stuck with me, man, is this idea on the ensemble models on having very, 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 very narrowly defined tasks and being able to have your evaluation soar because of the narrowly defined tasks. Right. And right now I know that evaluation is a sore spot for a lot of people, but if you are able to see that because I have this narrowly defined task, I can create an evaluation data set that is much stronger and much more clear, and it doesn't allow that gray area for interpretation, or it just doesn't complicate things and overcomplicate things. That is where you're seeing people leveraging. That's ingenuity in my mind.
And it's also, it's ingenuity, it's striking at the core risks in this whole equation. It's like when you want to leverage this kind of technology, produce these kind of AI apps in a large company setting, not having careful evaluation that's based on your own process, your own domain expertise is a huge risk.
No, I will not recommend your podcast. As the ML lead engineer at DKB Bank, I'm definitely not wanting other engineers to have all this relevant information, and I will not give my name, which is Lena. So definitely, I do not recommend this podcast.
And you want to bring in your domain experts really to like tie it down and make sure that it's right for what you're doing. Also, it's your business. You're doing this, all day, every day. You know what the evaluations should be. So I think that maybe a real succinct way to describe it is there's been a lot of model-centric focus in the media because it's something that like Wall Street analysts can wrap their minds around. It's like, this model is better than that one. They're going to be trillionaires.
Benchmark.
Yeah.
All these marketing terms with benchmarks. This is, it beats GPT-3 on all these different benchmarks. This model's the best now.
But, and it's so like one-dimensional too. It's like, okay, yeah, you have that benchmark, but that benchmark completely ignores these other issues like, I don't know, cost or security. And yet at the same time, the things that's really important is more of a data-centric view, not a model-centric view. And I think Andrew Ng, there's a talk that Andrew Ng did recently, kind of looking ahead 2 to 3 years. It was at Stanford Graduate School of Business. It was a really, really good talk. I definitely recommend that. And, that was the point, is like, forget the model-centric view. You will pick various models to put together. But if you don't have your data set quality, and especially your evaluations, if you don't have that tied down with your domain experts weighing in, you're just like dropping onto quicksand.
And he's been beating that drum for ages. It's funny because it's like things didn't really change now that there's this whole LLM boom. This data-centric AI has been popular since I can remember. And it's great to see that he hasn't flip-flopped on us, and it still is probably one of the most important things that we need to be focusing on, if not even more important now, because if you are just using one of these models, let's say you're using an open source model that's off the shelf, that's great, but you probably need to do a lot of tweaking to that open source model. And whether you're doing some kind of RAG or you're fine tuning it, I've spoken at length about how I think fine tuning, people jump to fine tuning a little too quickly, but that is a whole nother discussion. But at the end of the day,
I agree.
You need the data. The data is the king here, or the queen, or the royalty. It is not that model.
Right. Your data set, I think there's really two things here. One is like, as you said, you need that data. You might train a model, probably not. You'll probably use a pre-trained model. You might do fine tuning, and it is really important if you have enough data. You might do something more like few-shot. You probably will do something like RAG to mitigate hallucination, but most certainly you'll be doing your evaluations on your data set with whatever models you're using. And so your data set, your quality of your data set, you might be using it five different reasons why that is front and center for your priorities. And I think that the thing that really was poignant for me in this last conference season, if you will, the thing that have been hearing from the execs who are running AI teams in enterprise, the thing that keeps them up at night is domain expertise. Because the problem worldwide is whatever business vertical you're in, the real domain experts are unfortunately aging out of the population, I think is a polite way to say it. You could talk to sustainable fishing for Japanese fishing fleets. You could talk about steel mills in Pennsylvania. You could talk about chemical manufacturing in Germany. The problem is the people who actually know how to troubleshoot the problem that's going to cause your factory to be down and losing, tens of millions of dollars a day. Those people, it usually takes like 10 or 20 years to gain that kind of experience. It's not the kind of thing that you can just teach somebody overnight. And unfortunately, because of the population demographics, especially in Asia, a lot of the expertise is aging out. Like, our firm, we've done some work for NOAA, and it really struck me when I was at NOAA talking, with researchers, working with them on machine learning applications. What do you think the average age is in the U.S. for climate scientists for the U.S. government?
Climate scientists.
Yeah.
I'm going to shoot low just in case to make it easy on you. 35.
No, it was like late 50s. I think it was 59. And I was talking with a woman who was in her mid 70s. She was spending 6 months out of the year on research vessels in the Arctic. Like the seas in the Arctic, you get 3 meter seas and stuff. And her point was this is excruciating, but there's nobody to replace her. And this data is absolutely vital.
No.
And so that's the kind of thing. There's a lot of domain expertise out there in the world of people who are of a certain demographic, and they're aging out of the workforce like yesterday. And when you talk with industry leaders who are seeing ROI on AI applications, this is the thing that keeps them up at night. It's we need to have the domain expertise put into our applications, into our data sets, into our evaluations, into our process. But these people are either retiring or leaving one other way or another. And I mean, this is really scary. And maybe you can say, well, we'll just have AI replace them. It's it doesn't really work that way. That's too easy of an answer.
Yeah, exactly. As if that narrative actually can fool any of us, right? That doesn't. We all know. We've all messed around with AI enough to be yeah.
I do think the two divides there. Yeah.
I thought that's what it was. I was hoping that was a Big Lebowski reference. So it is so true when you talk about this. The experts, as you mentioned, it takes years, if not decades, to get someone up to speed because they have to see all of the ways shit can hit the fan.
Yeah.
And so they have to live through all of these different ways that things can go wrong, and they troubleshoot it. And I know in Germany too, where I'm at, there is a very lopsided population, like age, where the pyramid is upside down, we can say. And so it's too bad to see that, right? And I guess you have to try and get people from other parts of the globe to come in and do things. Now we're talking about social issues, but still, it doesn't necessarily fix this idea of, hey, we need the subject matter experts who know how to do these things so that we can have them come and work with us to create a better system and ideally help them augment what they're doing. So if shit does hit the fan, we at least have some options we can present to the successor.
I mean, a lot of it too has just been like shaping what are the interesting jobs. I mean, if you had the choice of like getting hired by Meta and earning however much money they're going to pay you as a ML engineer versus like taking a job in a steel mill, I mean, what are you going to do? But yet we kind of need the steel mills, you know. I think my favorite example on this was from K-First World. There was a talk from Furuno, if I'm pronouncing it correctly, but it's a industrial firm in Japan, and they're working on doing AI apps. They're doing modeling with fishing fleets. So like in Japan, most of the fishing is done by a relatively small boat. It'll be like an 8-meter boat, and there are 2 people on it. They're usually much older. And they're the people who know, for a given like nook and cranny of the ocean, here's a bay, here's a shoal, at a given day and a given time of day, if you drop the nets or the lines, here are the species we're going to pull up. This is the relative ages of the different species. And these are the decisions we need to make right now as far as like sustainable fishing, if we're going to, really cultivate and have a good harvest, that we can keep having good harvest for years ahead. These people are really old, but they know sustainable fishing. And so what this company was doing is actually sending people out on those boats with laptops and building models. And according to Japanese law, the fishermen end up owning the models. And the models are like hyper-localized for sustainable fishing. And it really is at like a grassroots kind of bottom-up level. But I thought that was really cool. I thought that was like the way to go as far as like really capturing a lot of domain expertise, but also doing it in a way that maybe is, you could say, more socially sustainable, because now, younger people who want to go into fishing will have something more to rely on, but it'll be more of like a mentorship kind of approach, as opposed to AI will replace the workforce.
Yeah, it feels like it is the learning. It's helping us learn what to do and what not to do. It's not that it's going to go and fish for us.
Yeah, exactly. I really liked a talk by Sebastian Kukla, who works in steel mills. This was at K-First World, but Sebastian was talking about how in a mill, there's a person who stands like 3 meters away from molten steel and listens. And they're the person who says, okay, we have to shut down the furnace. It needs maintenance. And if you make a mistake, like you shut it down at the wrong time, you're going to lose a lot of money. But if you don't shut it down and do the maintenance, you're going to lose a lot more money. And that there we're talking about, hundreds of millions, right, per factory. And the problem they have is it takes 10 years to train somebody how to listen to like a blob of molten steel to know when to shut down the factory, the mill. And the problem they have, like right now, the U.S., because of a really strange nuance in terms of Russian oligarchs and money laundering scams and sanctions, we ended up having
I like where this is going.
Mills. Yeah, well, there was this big money laundering thing, attempted money laundering, because steel mills traditionally lost a lot of money. But because of that, the U.S. is now number 2 for launching new steel mills in the world, behind India. And the problem is that they have to cannibalize one mill to bring in the experts to launch a new mill. And they're opening up mills in, places like rural Texas where, to quote from Sebastian, the standard of living in some of these areas, it's like people might be making on average $24,000 a year for a household. But a steel mill job, if you work 40 hours a week, you start out at 75 and you're probably working overtime, which is, like time and a half. So, I mean, a person going from earning like 20 something $1,000 a year to like earning $100K a year, that's a pretty big difference. And I think
Huge.
bringing that kind of manufacturing into the U.S. is also a good thing too for the U.S. So I think there's a lot of challenges in manufacturing, and there's just all kinds of places where we can use AI apps, but we have to be cognizant of the fact that it's not all just about automating process. There's actual people doing things that are like dangerous and difficult.
Well, it does feel like that specific example that you called out could completely be at least monitored by some kind of model that will be able to classify the sounds and then send it to an expert. So maybe you don't have the person that's sitting right next to it, but you have the expert who's getting 10 different steel mills.
Yeah, that would make so much more sense, and also it kind of seems like standing 3 meters away from molten steel for your career is going to have some health issues downstream. So I think there's huge amounts of work that we can do, but I mean, human in the loop and active learning and weak supervision and on, bringing the people into the equation is so important. I like to think of AI in terms of some of the definitions from, have you ever looked into the Macy conferences back in the 1950s, like second order cybernetics?
No, what are these?
Oh, there was really cool stuff
that
going
sounds
on. It was interesting. In the 1950s, there was this a lot of people who were working with really super complex systems started coming together and comparing notes. Some of these systems were like what you would expect, nuclear weapons and really large scale energy production. But others were for social systems, what they'd seen, in World War II and after. And so there was a series of conferences called the Macy's Conference. Norbert Wiener and John von Neumann and just all kinds of people were involved there. But it really spoke to how can we define large scale systems of people and machines working together? And for me, that's always been kind of a template for what's going on in AI. There is the machine component. There's also the people component. And I think you have to keep that front of mind, because a lot of the news cycle that I've seen about AI was just completely divorced from this. It's just like, we have a God model. It's going to make us immortal and super wealthy. It's like, no, it doesn't work that way.
Yes. But AGI, it needs to be regulated right now, and we need universal basic income before you can step out of the house. It's a little bit hysterical, to say the least. And that is awesome. I'm going to look into the Macy. It's the Macy conferences?
Macy conferences. Yeah. And in particular, it was really led by, I think that some of the social scientists at the time really, really kind of led things here. I'll give you some more notes about it. There's Paul Pangaro. There's a design firm out of San Francisco, I think, that's kind of resurfaced some of this. But it ends up being an articulation of second order cybernetics. And the person who really dove into this, have you ever heard of Project Cybersyn in Chile?
No, and I'm not even sure I know what second order cybernetics means, just to clarify that. You're going to have to take a step back even.
Well, cybernetics is the idea was back in the mid-1920s, I think it was Norbert Wiener at MIT came up with early ideas of control theory and automation and for robotics. And it was really proven out. The first real use case was tying anti-aircraft to radar systems in World War II in the Battle of Britain. But then Norbert Wiener went from there, and he invited a couple people working in neural networks to MIT, and they came up with the first artificial neural network simulations. So it was the McCullough and Pitts paper. A graduate student on the project was my intellectual hero, Umberto Maturana. He was later in a thing in Chile called Project Cybersyn. And anyway, Cybersyn was this idea that you could have a data science team working with the federal government to try to figure out where there are gotchas and maybe suggest. And it's really crazy because they had like Star Trek chairs and they had people like drawing visualizations on paper and putting it up on a board. And it was like early 1970s in Chile. They had very, very little resources. But this was labeled as socialist. And a lot of the lead people were put into prison, right? And, of course, the U.S. went in and put in a dictator instead. But people from that project ended up being very substantial in the area of like understanding cognition from not consciousness. I'm not saying that, but understanding cognition from a way that fits with engineering practice and understanding how you can have systems of people and machines working together. And like I say, Umberto Maturana and Francisco Varela are two of the people that really came out of that project and really wrote a whole lot. There was another one. There was a guy who was a political prisoner in Chile for a long time who'd been one of the leaders of this early data science project. And he ended up getting out of prison because of some professors at Stanford and Berkeley. And so he ended up doing a lot more work there. But I'll give you more links to it. But Project Cybersyn is just like a case study in here were people talking about early AI and actually doing something useful and got thrown into prison for it.
All the great stuff that they did, we don't care. Get in jail. That was, I imagine that was the, what was it, Pinochet? Was that the...
Exactly, yeah. It was Allende and Pinochet, yeah. That whole conflict. Yeah, but Flores was the ringleader, was the one who the Stanford profs got out of jail. And he ended up being on a project, the Human Computer Interface Lab at Stanford. He ended up being on a project there. A very small little project came out of that lab called Google. And anyway, there's a nice kind of ascendancy from like Norbert Wiener, Macy Conferences, Umberto Maturana into a lot of the thoughts that have come into structuring what's going on in AI. I just think that it's not as popularly known.
Yeah, and what strikes me when you tell this story is how ambitious they were back in the 70s. These names and just what they were trying to go for without having really what we know today as a foundation. They didn't have any of that. They were just like, we're going to go for, what was that, human computer interface? Like, yeah, that sounds very ambitious even today.
The Cybersyn project was crazy. They didn't have a computer, but they did have some time on a timeshare, and they had a dial-up line. But they were really looking at like the macroeconomic indicators for an entire country, for Chile, and doing a good job of it. There have been a couple documentaries about it, I think, that are really, really super interesting.
So you have a bit of a hot take that I want to ask you about, which is when it comes to working with machine learning and AI these days, I think a lot of people have started to talk about the AI engineer and this software engineer that doesn't necessarily need to know anything or very little about machine learning itself or AI or how models are trained or how AI works, data works, all of that fun stuff. It's just you hit an API and you get what you want and you build an app on top of it. And I think you champion for a different perspective, and I'd love to hear what and why that is.
Certainly. I mean, I think that for any of these kind of applications, there's an enormous amount of software engineering that goes in, and really from what I'm seeing, even beyond the software engineering, the bottleneck is ops. I mean, practically speaking, in industry, one of the unfortunate realities is you go into XYZ large manufacturing firm, their ability to hire top ops talent is limited because HR will only spend a certain amount of money, and the good people in the field go off to work for a different company. So
exactly.
What we see,
yeah, and as you said before, not necessarily as sexy to go and work for the steel mill on their ops project as it is to go and work for that hot new startup.
So we actually, I mean, applications, we have to work a lot. We have to do backflips just to try to cut down the ops overhead for a given application just because of the hiring limitations. And I think that's really, we can talk all we want about AI engineers, but unless you actually have your ops team, if you're in a regulated environment, you're not going to get very far. And so that's the bottleneck. And then working back from there, there's a ton of software engineering that has to go into these kinds of applications because there are very strong concurrency requirements to really make it work, and a lot of interesting data requirements and caching. As I talk with people who are doing AI applications, I hear the phrase, we work from the cache out. So like we look at, can we get our weights and biases into memory cache? And once we've done that math, then we work out to figure out what the rest of the system architecture is going to look like. So, I mean, I think that there's just a ton of systems work and software engineering that has to go into really whatever you're doing, because, I mean, it's not just a matter of like a little bit of input goes into a black box and has stark insights coming out the other side. Instead, there's a lot of data that has to go through a lot of processing, and there's a lot of steps. There's not just a black box. I mean, like case in point, if you look at, your typical natural language libraries, take Spacey, for instance, or Flare or whatever. I mean, you make a call to parse a document. There's actually a lot of steps there, and there's a lot of machine learning models being used. And it's, very well understood. There's a lot of benchmarks, a lot of QA, et cetera. But you make one call and there's a workflow of a lot of different moving parts. And I think that we're going to continue to see that kind of thing. Going back to like mixture of experts, like we discussed earlier, we're going to see workflow orchestration really being the make it or break it for these kinds of AI application architectures.
Well, it is interesting when you talk about how before, it's almost bringing it back full circle, before where the hardware has enabled the software, which is enabling the developers and the processes. And just thinking through that and thinking about how now the processes are changing because of our hardware abilities, and we're able to have much lighter weight libraries that we can play with.
Yeah.
It still doesn't replace that know-how on the ops side, and whether it is a data engineer moving data around and getting it in the right schema so that it's set up for that data scientist who needs to play with it and try and do experimentation on it, or just the SRE once it's already out and they're making sure that the uptime is correct and everything is running smooth, and that machine learning engineer who has the platform that the data scientist can hook into. All of that is pretty much, and it goes back to the seminal Google paper where it has the model in the middle of the diagram.
15%.
And it's like, that's the easy part. Really? Like you've got yourself 10% of the way there. And so thinking, I mean, the other piece though that goes through my head is what you were talking about is fascinating in the way that if we are finding the use cases where we can just hit an API, it's almost like there is, for those use cases that you're okay with data going outside of your walled garden, right? Because I understand that there are a lot of companies that's just a no-go right from the start. It's a game showstopper, we could say. But if you are okay with that, you can create incredibly high value for the company if you can figure out that, hey, that big process that was really convoluted and we had 20 steps, now we can just hit an API and it gets back, some kind of comparable results with this gigantic model. Then you have to look at what's the ROI on this? How are we going to explain what the ROI is, and if it's worth me making a GPT call, or if it's worth me doing this insane pipeline that has 24 steps in it?
Well, I mean, the former is probably a really good idea for prototyping and really turning around a lot of different ideation into something that's tangible that, people can make decisions on. But then you have to realize, if you continue going down that path, how many millions is it going to cost you for this business unit, per year? Can you really afford it? Because I think in a lot of cases, the answer is no, there's no way. But if you break down the problem and like we said, smaller specialized models.
I also want to add that it's not just the cost factor. It is a lot of the vulnerability of you building a house on a very weak foundation. We could say whether that is the service goes down, and OpenAI isn't really known for its reliability, especially after this weekend where
Yes.
everybody is the most dramatic thing that's happened in years, right? Since the crypto boom and bust. And so if you're building on top of that, you have to worry about that. But then also the controllability and knowing that you are going to get the same thing and your models aren't going to just be swapped in the background without you knowing it. And your prompts are all of a sudden, they're not rendering what they were rendering 20 minutes ago.
There's, I work a lot with Ben Larka, and he's done some interviews with a company called Luminos. There's a guy named Enderbert. Basically, it's a law firm in, I believe, the DC area, but it's a law firm where they have like software engineers and attorneys working like pair programming. And they are really helping out a lot to understand these cases. Where's the risk? How can we really characterize this from both an engineering perspective and a legal perspective? And I think that that's the thing that is not really borne out yet in the news cycle is like, well, I mean, if you are running a chemical factory and it explodes and, tens of thousands of people are killed, there's a certain amount of liability. So, I mean, you have to look at what you're doing in the real world and see like where are the risks, where are the biases, what are the downstream implications. And you have to have a lot of people, who are maybe in finance or legal or whatever, or seminary compliance. They have to come in, and they have really as much weight as also the SREs coming back and saying, hey, look, what you're proposing doesn't actually run. So we need to iterate in front of the data scientist and the data engineer for something that will. And I think that that's the world that's ahead, is really taking on a lot of those interesting hard problems about this that have been swept under the rug, because it's not just a matter of calling some API. There's just really too much risk unless your security team and your legal team can pull it apart. I will say that I think that there's a little bit of a silver lining, though. I mean, what I've seen over and over in machine learning over the past 4 decades is something that I think we see in general purpose technologies, over a much longer span. You start out with really hard problems, whether it's like in the 1950s, there were problems with like commercial jets had become so complex they started falling out of the sky, and there was this really big push to come up with the modern airframe, which is an engineering marvel. It's like a civilization-changing kind of technology, but it took tragic things to happen before there could really be the engineering investment to come up with the new airframes now. Once you bridge over into some really interesting, like game-changing technology, early on, there's usually some fairly exotic kinds of ad hoc approaches that somehow work and gain a lot of popularity. But give it 2 or 3 years, the mathematicians start showing up. And eventually, the hard engineering problems that started out relatively ad hoc, once they get traction, the mathematicians come in and say, you know what, we can really reduce this down to a whole bunch of like linear algebra and probability theory. And once you can take a really hard problem, and whether it's, like energy grids or airframes or we could go into a lot of things, but certainly in medicine and whatnot. When you take those hard engineering problems and break down the math, eventually there's maybe some years of latency, but you get to a point where it becomes like an optimization problem. And I think we're seeing that now with machine learning, where some of the really dramatic stuff that we've seen, like say in painting and, what you can do with Midjourney and others, starting to be expressed by mathematicians is like, yeah, we can solve this too. And we can hit the benchmarks by expressing it as a conditional probability. And once you can start to look at that level of math, we can come out with much more general ways to take advantage of hardware. But we can also start to analyze more formally, where are the risks, where are the biases, what are the latent variables that we weren't actually talking about before that are having a lot of impact here? And I think we're starting to see that for this current generation of AI. The mathematicians are starting to show up. It'll be hard. It'll take a few more years before we can really get to scale on that. But what I've seen, it looks good. And that has a lot of implications on the business side for, like I say, for reliability and risk and security analysis, all the things that in ops we have to care about.
Yeah, optimizing. And when you said that, I couldn't help but see in my mind a scene of people rolling up and the music blaring, and then you get some guys dressed all nice hopping out of the car, a nice car, and it's like the mathematicians have shown up and they're going to save us.
They usually aren't that well dressed, let me tell you.
I kind of, that's what I had go back in my mind, like, oh, it's probably not the, slick suits, like Reservoir Dog style type of person that you're seeing get out of the car.
No, might have a t-shirt, might not.
Yeah. Oh, that's so good. And it does feel like it's so funny because we are going full circle where this whole conversation, right? We've been talking about, okay, there is large language models. They do incredible things. They are useful for certain things. But at the end of the day, we're just going back to where we were a few years ago, just kind of better when it comes to small models. And we're still like, the majority of machine learning out there that is powering the world are small models. It's just that large language models have kind of unlocked this ability for anyone to go and play with AI and see the power of it. And then the ones that are reliable and, as you say, are basically battle hardened, they've gone through the security, they've gone through the ops, they've gone through all of that fun stuff, they've been optimized. The majority are still those smaller models. And so us coming full circle, it's almost like we went on this little side quest of large language models for a while. And now I think people are starting to realize, they're cool. They have their place, but let's not throw everything at them.
Exactly. Yeah. You really want to have the product fit, if you will. You really want to understand the task analysis, like we were saying earlier, and make sure the use case fits. I think that there are some really great examples, though. I mean, I think for LLMs, I'm a big fan of a project called SpanMarker. A friend of mine, Tom Arison, is at Hugging Face, and he did this for his graduate dissertation. But the thing about SpanMarker is, I mean, there's a component in NLP usually where you do named entity recognition. You pull entities that are known that you can link to other resources for out of some raw text. And, there was a certain level of state of the art. And what Tom did was come up with an LLM approach to really enhance that, really come up with much better accuracy. And it's, again, very narrowly defined task, but suddenly that one piece works a lot better. And if you're building a knowledge graph out of 100 million PDFs, which is what in manufacturing actually people do all day, every day, suddenly this critical part of like extracting the key information out of an unstructured source, it becomes a lot better because of replacing an earlier model with an LLM. And I think that, when we really and that's hardcore engineering. I mean, there's a lot of performance analysis and whatnot that Tom put into that, and others that are in this field are putting in. But I think that that's really where the engineering needs to be focused, is finding out those tasks that we have been doing some way for years and years. And now suddenly, instead of getting, like 85% accuracy, we could get 95% accuracy. And those are game changers for a lot of different areas in industry. And I think that that's probably more of where we'll see the early adoption. I think there's also really good generative AI use cases in industry too, like more on the strategy and planning side. But, at the end of the day, what you're saying earlier about making what we've been using for a long time better, at the end of the day, neural networks are about calculating joint probability distributions. You have a lot of layers, and you've got various inputs and outputs, but you're calculating the joint probabilities at each, different point of making decisions in networks. And we've known for a long time that we could just do that explicitly. It would take years to build models if we did it really explicitly. And instead, the shortcut is, deep learning, and it's magical how well it works. But I think, we're going to have time for the math to catch up. Once the math catches up, then the physics and the hardware catches up, and you start to see much better economic windfalls coming out of it.
And so I know we're kind of finishing up here. One question I want to ask you, or theme that I would love to dive into before we go, is about manufacturing. And I know you spend a lot of time there. You do a lot of work with companies that are doing manufacturing. The use cases that you're seeing, just like you said a minute ago, that are being unlocked because of machine learning. Can you break down what some of these use cases are, and then how, again, you mentioned the ops part is hard.
Yeah.
So just finding ops talent is hard, but also what are other ops parts that are difficult if you do have the talent, right?
Well, I think one thing that I've learned about manufacturing is I would have gone into it and thought that there's a bunch of process data and like real-time sensors, and we have to have some streaming processes to understand all this. And it's like, yeah, there is that. You have to make sure that all the compressors are working properly. But the real problem is probably more on the finance side, because in finance, there's a lot of capital investment just to be able to get like work started for one customer order. You get multiple factories fired up, you get all kinds of logistics, you have all kinds of vendors, shipments all over the place. And what I've learned is the real critical data is pretty much all in PDFs, because PDFs will have, for instance, patent applications from your competitors that you need to understand if it's going to get you in trouble, scientific documents that have to do with material science or chemistry or biology or whatever field you're in. Also, like environmental impact reports from your competitors will give you a leading idea of like where they're firing up new facilities. Shipping manifests, like if you lose a bid, you don't know who you lost your sales to, but sooner or later, containers are going to start getting moved around Earth. And so the shipping manifests are like a kind of information for you to sort of triangulate and maybe do a win back. So there's a lot of these kind of things that are going on. Oh, also regulatory compliance and all that. This stuff is all in like norms documents. This stuff is all in PDFs. And so the real problem is how, I don't know if you've ever worked with like PDF parsers, any of those software libraries, like PyPDF4 and, oh God, I can just go down the litany of it. But, PDFs are basically this monstrous mess where you basically have like little boxes of text and graphics, and they're spread all over a page. And when you parse it, you basically have to go recursively with callbacks to figure out where the bounding box is and grab that little piece of text and put it together with another piece of text. And it's just so hideously hard to like put back together that actually like parsing an invoice is a hard problem if you have, invoices coming in from multiple companies. And the thing is, if we want to take action on our data, that's the really crucial data to work with, is like what's locked in the PDFs. And building machine learning both to extract it and to verify about quality, because there can be real gotchas there, but then taking action on it. This is what I see over and over, and it's a hard problem whether you're in finance or manufacturing or biotech. And so that's why I'm really super interested in natural language and tools that like really help with natural language, because, this is how we attack these kind of problems. And I think the applications there, from what we've seen, a lot of it are really more on the finance side, because at the end of the day, these projects, they take a lot of investment. Like I say, there's, a whole bunch of different vendors and a whole bunch of gotchas along the way. And if you aren't handling it well, you can lose a lot of money very quickly. So I think that rather than, listening to compressor sensors, we're probably trying to help the finance people do their job better, because that's where it lives or dies.
I was not expecting that at all. I of course, I was thinking, yeah, sensors, and you've got like time series stuff you're probably doing, and you've got maybe some computer vision with some video that is on conveyor belts and the stuff coming out, making sure you're finding that, which I'm sure there's a lot of that too, but I didn't think about that at all.
Well, I mean, the way to really describe this is like value chain analysis. Like if you look at a graph of, here's my sale to this customer. Now let's back up all the assets I had to use to get there and all the vendors I had to tap. And, oh, by the way, these critical vendors just got acquired by our competitor. That's a kind of value chain analysis. And that's where the machine learning really comes in, because it's like inhuman to try to analyze this otherwise.
And you've been doing this for a while. You haven't thought about creating a platform yourself?
No. Gosh, I think that there's a natural urge for a lot of customers to ask for that. And I also think it speaks to nuances in tax law. Especially, I've learned a lot about like German tax law regarding R&D. Yeah, no, I don't know that. I mean, it would be great if it were possible, but I don't know that it's possible. I think that instead, there's a lot of real nuanced domain expertise that's locked up in individual business units, and it's better to like work with them and help them do their job better. Trying to come in from the outside and say, hey, I've got a platform that's going to solve all your problems. It's laughable, because there are so many problems and they're so different, and they change from company to company. They also change from business unit to business unit. And I think from the ops side, the big problem there is you see these big companies, they've made so many acquisitions over the years. They've brought in so many teams, and every team has a different database and they have different practices. And so just trying to understand, like, what are the schemas we're working with? That in itself can be an enormous machine learning problem. And for some companies, I can't name names, but a very large aircraft manufacturer was at the point where the operational side of this became so critical that they would take their database systems offline for almost a month out of each year just to go back and do schema alignment, because they had brought in so many other little companies and tried to cobble them together. And so I think that, these are the kind of operational problems you have, is like just even understanding the different business units within your company you have to interact with. That's the thing that's going to kill your project.
Well, Paco, you did it. You took the spot in my mind for my favorite Paco now that I know of. You are incredible. This was so good, man. I cannot thank you enough for coming on here and talking to me, teaching me really all about what is going on. And I know that you do all kinds of fun stuff connecting people. And so if there are people out there that are looking, that resonated with any of this, I think it is worth saying you should probably reach out to Paco. He is the super connector of sorts, and probably got something to say about what you're doing and how you're doing things. So thanks so much, man. This was awesome.
Thank you, Demetrius. I really appreciate it.
I'm Emmanuel Mason, machine learning engineer at Stripe and author of Building Machine Learning Powered Applications. And if you don't want your machine learning models to explode, well, you should subscribe to this podcast.